Hello everyone! In this video, we're going to discuss critical points and points of inflection. But what is a critical point and a point of inflection? Critical point is a point where the value of y prime changes its sign as x increases. It is also the point where y prime vanishes, and it can be classified as the minimum point or the maximum point. Now, we have to remember that y prime can also be interpreted as the slope of the curve at any given point. So, we can also say that if the value of y prime changes its sign, say from positive to negative, as x increases, then we can also say that it is the point where the slope of the curve changes from positive to negative, right? Whereas the points of inflection are the points where the curve changes its concavity, and it is the point where y prime or y double prime equals 0. So let me explain the concept of critical points and point of inflection using this illustration. So we are given a function y equals 2 plus 12x minus x cubed, and the graph of that function is this one. Alright? So the critical point in this function is the point where the slope of the curve changes from positive to negative or negative to positive. And the point of inflection is the point where the curve changes its concavity from concave upward to concave downward or vice versa, right? So at this point, let us take this point as an example. So if I'm going to draw the tangent line, all right, so say for example at this point, this is the tangent line at this point, and the tangent line at this point can be drawn by a straight line as well, and the tangent line at that point can be drawn by, alright, so that can be drawn by a horizontal line. Okay, so in here you can see that the slope of this line at this point, alright, is negative, and the slope of this line at this point is positive. And at this point, the slope is equal to 0. So if at this point, the slope is equal to 0, then, and we can interpret the slope being equal to y prime, therefore, this point is now the critical point. So similarly, if we're going to take this point as an example, if we're going to draw a tangent line at this point, right? So if we're going to draw a tangent line at this point, here's our tangent line, and at this point, say for example, we're going to draw a tangent line at that point, and if we're going to draw a tangent line at this point, it can be seen that at this point, the slope is positive, and at this point, right, the slope is negative. Now at this point, the slope is equal to 0. And it is obvious that there is a change in slope from positive to negative. Therefore, we can say this point is also a critical point. Alright? So how are we going to determine whether a critical point that was solved is a minimum or maximum? So in here, we're going to use the first derivative test. And using the first derivative test, we can say that if there is a change in sign from negative to positive, so if y prime, alright, changes from negative to positive, the critical point is minimum. And in this illustration, we can see that if there is a change in slope from positive to negative, right, then it is a maximum point. So using the first derivative test, if y prime changes from positive to negative, then the critical point is maximum. Right? So that is the concept of critical points. Now, for point of inflection, the point of inflection is the point in the curve where the concavity of the curve changes from concave upward or concave downward. So, since y prime, right? So, since we can relate uh, y prime as the rate of change of the function y, then we can also say that y double prime is the rate of change, right? So, is the rate of change of y prime as x increases. So, if the value of y prime is increasing, then it is concave upward. However, if y prime is decreasing, right? So if the value of y prime is decreasing, it is concave downward. Alright, so if we're going to look at our graph here, so this is the graph of the function y equals 2 plus 12x minus x cubed. So if we're going to look at the graph in here, and say we're going to take this region, right? And then we're going to draw the tangent lines in this region. So we have this point, this point, this point, and so on. Right? So if we're going to draw the tangent line at this point, at this point, at this point, right? And at that point, there we go. It is obvious that in this region, alright, so as x increases, the tangent, alright, so the slope of the tangent lines also increases. And if the slope or y prime increases, it is concave upward, right? So similarly, if we're going to take this region, right? So if we're going to take points in this region, say for example, this point, this point, and this point, and this point, and if we're going to draw tangent lines of these points, we have this tangent line, right? So we also have this tangent line, and the slope of this one, and this one, right? And so on. Now, you can see that at this region, as x increases, the slope of the tangent line decreases. And if the slope, which is equal to y prime, decreases, then the graph is concave downward. Now, the point where the graph changes from concave upward to concave downward is what we call the point of inflection. Right? So that is now the point of inflection. Now, let us start solving examples. So in here, the instruction is to locate and classify critical points. So we're going to locate the critical points, and then we're going to classify whether it is a maximum or a minimum point of the given function. And also, we are going to locate the points of inflection, right? So for the first function here, we have y equals 2 plus 12x minus x cubed. If we're going to locate the critical points of this one, first, we're going to solve for y prime. And y prime of y equals 2 plus 12x will give us 12 minus 3x squared. Right? Now, if we're going to simplify this one, we can actually factor out 3 in this expression. So if we're going to factor out 3 here, we have 3 multiplied by 4 minus x squared. So 4 minus x squared is a difference of 2 squares, And if we're going to factor out difference of two squares, this will now be equal to 3 multiplied by 2 minus x multiplied by 2 plus x. So this is now the simplification of y prime, all right, in its factored form. So solving for the second derivative, so we're just going to take this one because this is basically equal to this one. This is just the factored form of 12 minus 3x squared. So the second derivative of 12 minus 3x is the second derivative of 2 plus 12x minus x cubed will now give us y double prime equals negative 6x. All right, so in here, the second derivative is the derivative of the first derivative, and the first derivative is the derivative of the given function, of course. So, solving for the critical point, we're going to equate y prime to 0, and solving for the points of inflection, we're going to equate y double prime to 0. So, equating y prime, right? So, let us first solve for critical point. Right? So solving for critical points. So in solving for critical point, we're going to equate y prime to 0. So this will now be 0 equals 3 multiplied by 2 minus x multiplied by 2 plus x. Or if we're going to divide both sides by 3, this will give us 0 equals 2 minus x multiplied by 2 plus x. Thus, the roots of this equation would now be x equals 2 from this factor, and x equals negative 2 from this factor. Because if we're going to equate 2 minus x equals 0, then that will give us x equals positive 2. And if we're going to equate 2 plus x equals 0, then that will give us x equals negative 2. So these are now the x coordinates of the critical points. Now, solving for the y coordinates of the critical points, we're going to substitute these values of x to the original function, right? So to the given function. Now, let me just rewrite the given function here. So the given function is y equals 2 plus 12x minus x cubed, right? So that is the given function. So solving for the y coordinate of x equals 2, so this will give us y equals 2 plus 12 multiplied by 2 minus 2 raised to 3. And this is now equal to 2 plus 12 times 2, 24. So that will be 24 plus 2, 26, minus 2 raised to 3, so that is 8. So 26 minus 8, that will give us positive 18. And if x is equal to negative 2, y is equal to 2 plus 12 multiplied by negative 2 minus negative 2 raised to 3. Right? So this is now 2 plus 12 times negative 2, so that is negative 24. So that will give us negative 22. Minus negative 8, so minus negative 8, so that will give us positive 8, so negative 22 plus 8 will give us, right? So will give us negative 14. Thus, the critical points are located at points 2 and 18 and negative 2, negative 14. Right? So these are now the critical points of the given function y equals 2 plus 12x minus x cubed. Right? Now, the next thing that we're going to do is to classify whether these points are maximum or minimum. And to do that, we're going to perform the first derivative test. Right? So we're going to perform the first derivative test. Now, how are we going to perform the first derivative test, right? So in here, we're just going to take the expression of the first derivative, and the first derivative was solved to be y prime equals 12 minus 3x squared. So let me just rewrite the first derivative here. Y prime equals 12 minus 3x squared. Now, if we're going to classify this point, right? So let me just write it here. The first point is 2 and 18. So in using the first derivative test here, we're just going to substitute a value of x, all right, in the first derivative that is less than 2, and we're going to substitute a value of x also, all right, to the first derivative, which is greater than 2. Now, if the value of y prime changes, right? So if the value of y prime, let me just write it here so that you can remember, if y prime changes from positive to negative, right? So from positive to negative as x increases, then the critical point is said to be maximum. Alright, so however, if y prime changes from negative to positive as x increases, then the critical point is said to be minimum. Alright? So let us just try to classify if 218, if point 218 is a maximum point or a minimum point. So here is the first derivative. So if we're going to draw a line in here, right? So if we're going to draw a line in here, and this is x equals 2, this is x equals 1, and this is x equals 3. So if we're going to substitute 1 in here, y prime would be, right? So that would now be 12 minus 3 multiplied by 1 squared. So this is equal to 9. So y prime equals 9. So that is positive. And if we're going to substitute 3 in y prime, then y prime is now equal to 12 minus 3 multiplied by 3 squared. So this will give us 12 minus 27. So that is equal to negative 15. So this is negative. Now, you will notice that as x increases, there is a change in sign from positive to negative. So if that's the case, changes from positive to negative, the critical point is a maximum point. So this point 218 is a maximum point. Alright? And the second critical point, which is negative 2, negative 14, so if we're going to classify that one, negative 2 and negative 14, right? So if we're going to draw a line in here, this is negative 2, this is negative 3, and this is negative 1. Now, if we're going to perform the first derivative test, y prime is equal to 12 minus 3 multiplied by negative 3 squared. So this is equal to, so negative 3 squared will give us positive 9 multiplied by negative 3, so this is negative 27 plus 12, so that will give us negative 15. So this is y prime, right? So y prime, if x is negative 3, is negative. And if x is equal to negative 1, so this will now be y prime equals 12 minus 3 multiplied by negative 1 squared. So this will give us 12 minus 3 multiplied by 1 squared. So that's now equal to 9. Alright, so positive 9. Now, y prime changes from negative to positive. And if we're going to recall, if y prime changes from negative to positive, as x increases, therefore the critical point is said to be minimum. So, this critical point is a minimum point. Alright, so that is how to locate and classify critical points. And for the last requirement, we're going to solve for the points of inflection. Alright, so points of inflection. And solving for the points of inflection, we're going to set y double prime be equal to 0. And if we're going to recall with our solution, y prime was solved to be negative 6x, right? So if we're going to set y prime equal to 0, and since y double prime is equal to negative 6x, therefore 0 is now equal to negative 6x, or the points of inflection is located at x equals 0. Right? So if x is equal to 0, what is the value of y? So to do that, or to solve for the value of y, we're going to substitute x equal to 0 to the given function. And the given function is y equals 2 plus 12x minus x cubed. Right? So if we're going to substitute x equal to 0, right, at y equals 12, 2 plus 12x minus x cubed. So this is the given function. So this would now be equal to y equals 2 plus 12 multiplied by 0 minus 0 cubed, or that is simply equal to 2. So if x is equal to 0, then y is equal to positive 2. So the point of inflection is now located at 0